Yeah, it's from 9-5.
Yeah. I just don't want
That would be.
that.
Then I
Then you
know
probably
exactly what
understand
you're
what I'm trying to say. What do you usually go over in your exercise?
Whatever you guys are covering that week, typically. It's a smaller group than really whatever you guys want to talk about.
I don't know. I'm kind of indecisive, so I don't really care. I think it's okay. Like when it's smaller, like oh.
Like these ones really like I put them weird now and like I didn't really going.
Yep. That only has one step in it. I'll give you an
Okay,
example.
the ones that have more
with-
steps, I just
Yes. So, if you have 2.9 liters of concentrated hydrochloric acid. We'll say 2.9 liters of 15 molar hydrochloric acid. How many atoms of chlorine do you have? Okay. 2.9 liters of 15 molar hydrochloric acid. How many atoms of chlorine do you have? What are your names?
Molly, Scott, Johnny.
Molly, okay. So where do we start?
With the one that's named Molly.
Okay. So where do we start? Okay, so we start with the liters. What do we want to get to?
The atoms, the
Atoms. Can we convert liters to atoms? No. What can we convert liters to? With the units that we have available. We could convert to milliliters or microliters. In this case, not. So what is this unit here? What is 15 big S?
Oh, you can convert that to.
All right, what does, so that is molarity. All right, so we have 15 molar solution. What is another way to write molarity? Oh. Oh. What are the units of molarity? That's part of it. So if you have a 1 molar solution, what does that mean? So molarity is in units of moles per liters. So if you have a 1 molar solution, that means you have 1 mole of whatever it is you're working with in 1 liter of solution. So moles per liters. So seeing this, if we're starting with liters, we can use that conversion to convert to what? To moles, right? We can go liters to moles with that conversion, because liters would cancel and we'd be left with moles. And then we can convert our moles to atoms. Start with 2.9 liters. What are we going to do next? Okay. Yep. So we have 15 moles per liter. Our liters cancel. Now we're in units of moles. How do we get from units of moles to units of atoms?
You find the molar mass.
The molar mass would take us from moles to grams. We want to get from moles to atoms. Is there a different number we can do? How do we convert
It
from
has
moles?
something to do with the hydrochloric.
No, not yet. How do we convert from moles to atoms? Moles to atoms. That is with Avogadro's number,
Oh, yeah.
which tells us that there are 6.022 times 10 to the 23rd atoms in 1 mole. 6.022 times 10 to the 23rd atoms in a mole. Atoms or molecules or particles or anything here. We can have a mole of chairs. That just means we have 6.022 times 10 to the 23rd chairs. So what are we going to do next?
It's all hydrochloric acid.
Not yet. Well, right now we're still in moles. Right. 6.022 times 10 to the 23rd over 1 mole. What is my unit up here right now? Is there a better word that we can use there? Because it's technically not atoms. No? What does this tell us? No? We had moles of what? When we converted to moles, we had moles of what thing? No, not moles of clear. No, moles of hydrochloric acid. So hydrochloric acid is an atom. Either we would say that it's a molecule or a compound. The molecules of HCl. Really, it's an ionic compound, but for you guys, we can say molecules. Not whole. So now we're in units of molecules of HCl. How do we go from molecules of HCl to atoms of chlorine? Yep. So we're going to need to use the number of atoms of chlorine per molecule of hydrochloric acid. And how many molecules of chlorine, or how many atoms of chlorine are in each molecule of hydrochloric acid? Hydrochloric acid. You remember your acid naming.
I didn't say that out loud. Hold on, I got it.
So when you're naming acids, so we can have hydrochloric acid.
Oh wait, I found it. Oh no. I found the number.
We can have
Wait, the egg means 3.
perchloric acid. The egg does not mean 3. Wherever you found that in your notes, you should make it go away. Because egg never means 3. And we can talk about that in a minute. I know how you got to that, but we'll talk about later. Okay. So, when we're naming acids with chlorine, we can have hydrochloric acid, perchloric acid, chloric acid, chlorous acid, and hyperchlorous acid. What's the difference? They're what?
First word. The O's and the X's.
Okay. So the first three are just the same. Okay.
Yeah, different, like,
All right. Whenever you have hydro something ic acid, that's going to be a monoatomic acid. So that's using the ion just Cl. And what's the charge on chloride? What's the charge on the ion of chlorine?
minus
-1, because it's in the 7 group. So Cl minus is our ion. What's the charge on hydrogen when it becomes a proton?
it's still positive.
+1. So when this becomes an acid, we have H plus and Cl minus. 1 and 1, we can switch our charges. Ultimately, we get to HCl. HCl. Let's talk about perchloric acid. So all of these are polyatomic acids. So their ions are polyatomic ions. You remember talking about your polyatomic ions? Yeah. Yeah. So the ion here is perchlorate. So for your polyatomic ions, if is the acid of your polyatomic ion that ends in 8. So for perchlorate, that becomes perchloric acid. So 8 becomes ic. Moving down the line, we have chloric. So what do you think that polyatomic ion was? Chlorate. What about chloris?
That one was is that the I? Yeah.
IgE, ike. So this becomes ike. This is going to be chlorite. So what do you think hyperchlorous acid? What do you think the polyatomic ion that forms that is? Hyperchlorite. Double check something. It's going to be hypo. Minor. Hypochlorite. Hypochlorite. That's hypo. Okay. So now we get to the point of identifying your polyatomic ions. Any idea what each of these are? Perchlorate, chlorate, chlorite, and hypochlorite. Yes, the molecular formula.
So with the dates or the onions of using like 3 and 4.
3. No. The number, there are no numerical relationship to the 8s and 9s. We'll talk about that once we get through that acid names. Perchlorate is ClO4 minus. ClO4 minus. What do you think chlorate is? ClO something.
3.
ClO3 minus. The charge doesn't change, just the number of oxygens. So if perchlorate is ClO4 and chlorate is ClO3, what is chlorite? ClO2, -1 charge, and hypochlorite is ClO, -1 charge. So when each of these becomes their respective acids, we get HClO3, HClO2, and HClO. The number of hydrogen isn't changing because the charge isn't changing. The charge on all of those is -1, so they come together with 1 proton when they become an acid. So when naming your polyatomic ions, this template is the same. So you have per something 8, that thing 8, that thing 8, and hypo, that thing 8. Not all of your polyatomic ions will have compounds that actually exist over that full stretch, but they'll follow that pattern. So for example, we have sulfate and sulfite, nitrate and nitrite, and phosphate and phosphite. Do you remember any of the compound formulas for these?
For the sulfide, sulfate, is it SO? SO3,
SO4 2 minus is sulfate. So knowing that, what do you think sulfite is?
SO.
What's that?
The negative one.
No,
3?
no. SO3 2 minus.
Oh.
So remember, the charge isn't changing, just the number of oxygens. What about nitrate and nitrite? Either do you think at least one of those would be?
Nitrite, is it NO? The straight bond with the charge of the charge
No. No. For which one? And
For
what's your
the
formula?
nitrate.
Nitrate, and what did you say? NO what?
Is it NO negative 3?
No. Nitrate, NO3 minus. NO3 minus.
Nitrate.
Nitrate. So what do you think nitrite is?
NO with the minus at top and
NO2 minus. Good. What about phosphate and phosphite? Any idea what at least one of those would be?
for sulfate, is it SO charge of negative 2?
Phosphate is PO4 3 minus. Phosphate is PO4 3 minus. So what is phosphite?
PO 3 minus at the top. 3 at the bottom.
PO3 3 minus. Very good. So, what this demonstrates is that we follow the system based off of, let's say, up this area with increasing number of oxygen atoms. But the number of oxygen doesn't necessarily correspond to a substance. So nitrate has 3 oxygen, but sulfate has 4 oxygen. So the number of oxygen doesn't necessarily matter, where the 8s and 9s and the pers and the hypos. What matters is their relation to other compounds of that atom. So for fluorine, if you know one of these, you can figure out the rest, right? Because it's going to go up and down based off of this one. Same thing with these. So the number of oxygen doesn't correspond to a naming, rather the relative amount compared to other polyatomic ions with the same set of atoms. Any questions on that? That's why I say it's pretty well.
I got it.
All right, back to this. So, we're in molecules of HCl right now. We need to get to atoms of chlorine. What is our conversion factor between HCl and Cl? What I'm going to put here in this fraction. How do we convert from HCl to Cl? one molecule of hydrochloric acid to one atom of, yep. So in this case, it's a 1-to-1 ratio. It wouldn't necessarily be though. Does that make sense?
So you just put the chlorine at the top.
Yep. Our molecules of hydrochloric acid would cancel. We'd be left with atoms of chlorine, and we would get an answer from there.
How do you know if it's like 1-to-1 ratio? Is there cases where it's not a 1-to-1 ratio?
And that comes back to knowing how to go from a name to a compound. So if I instead asked,
Oh, like different charges, like positive.
let's say, we'll do a second example of this. We're making good progress on it. So for our second example, I'll use sulfurous acid. And I want to know how many atoms of hydrogen I have. Atoms of hydrogen. So you have a template to work off of. So use that and what you know to try to work through it on your own. I will be right back.
Hello. This is Jillian. I am. Hi, Sandy. How are you? Oh my goodness. I'm so sorry. I was trying to make you out for Easter. Oh, no. Okay.
In sulfide, do they become hydrogen?
Um,
In sulfates.
I'm so sorry.
Let me know how it goes.
Yes, I will. Let him know I said thank you very much.
your answer?
No.
Okay, how far did you get? Walk me through it.
So I know, like, there's SO with like a charge of negative, like 2 negative, and there's 3. I'm really confused on like where the hydrogen comes in play.
Okay. So, sulfurous acid. Sulfurous acid. So what polyatomic ion forms sulfuric acid? Yeah, but what is the
Oh, hydrogen.
formula? Oh, not hydrogen. So we're going to start with just the polyatomic ion. So sulfurous tells us we're working with what polyatomic ion?
Sulfide.
Yep.
So the SO, 2 negative, 3.
SO3 2 minus, right? So if that ion, how many hydrogen are going to bond with it? Oh, if we have H plus and SO3 2 minus, how will those come together?
Well, there's a charge of +1 of the hydrogen.
Yep.
There's 2 negative.
Yep.
So do I need 2 hydrogens?
Right. We could cross these over. We get H2SO3. That is what our sulfurous acid is. It is H2SO3. So work it from there to try to determine, try to get an answer.
So for the ratio, 32 on top.
What's that on the top?
So for the ratio, the 2 hydrogen for the ratio, you're getting 5?
No. So everything at the beginning is the same, right? 2.9 liters over 1 times 15 moles over liters times 6.022 times 10 to the 23rd over 1 times, so here's where we're stuck. So for every 1 molecule of H2SO4, or sorry, H2SO3, we have 2 atoms of hydrogen.
Okay.
And then we could multiply out and you would get your answer there. Any questions on these examples? Okay. Is there anything else you wanted to talk about?
I don't think so. I think I just need to like read a few things.
Flashcards for your friend. Especially with the polyatomic ions.
Do you have like a Google page by chance? I'm just wondering.
I do not, but I am on your class Moodle page. And I've emailed out a few times from that. So you'll have emails from me through Moodle. It will come to your email. It'll also come in your Moodle inbox. I have links in there to when we have good discussion, I record them and post them to YouTube. You have a link to view. I also have a Zoom option. So if you can't attend in person, you can hop into the Zoom call and I have that up. And I put the times that I need for 108. Anything else? All right, you're welcome.
Thank you for helping me.
You are very welcome. You have a wonderful night. Thank you.